Welcome to this training module on international rectifiers control ICs for energy efficient fluorescent ballast applications. This training module introduces the IRS2158D ballast control IC, its key functions and some design considerations. Fluorescent lamps are popular due to their low profile and high lumen per watt output. These lamps require a current for a specified time to preheat the filaments and a high voltage for the ignition and running power. The functions performed by present-day fluorescent electronic ballast include electromagnetic interference filtering to block ballast-generated noise, rectification, power factor correction for sinusoidal input current, undervoltage lockout and fault protection, half-bridge switches with driver and timing for high-frequency operation, and final output stage to power the lamp. The IRS2158D is a fully integrated, fully protected 600-volt ballast control IC designed to drive all types of fluorescent lamps. It is a linear dimming ballast control IC with half-bridge driver in a compact 8-pin form factor. The device provides a competitive solution to replace inefficient incandescent bulbs in multi-level and three-way compact fluorescent lighting applications. Requiring only small external components, the IRS2158D significantly simplifies and shrinks circuit design and delivers a dimming system performance of up to 10% for compact fluorescent lamps as well as linear ballast. The device features are listed here. Here we have the functional block diagram of the IRS2158D. This illustrates the state diagram of the IRS2158D. Under different conditions, the control IC goes to different modes, including undervoltage lockout mode, preheat mode, ignition mode, pre-run mode, run mode and fault mode. The undervoltage lockout mode is defined as the state the IC is in when VCC is below the turn-on threshold of the IC. The IRS2158D undervoltage lockout is designed to maintain an ultra-low supply current of less than 500 microamps and to guarantee the IC is fully functional before the high and low side output drivers are activated. When the voltage at VCC exceeds the IC startup threshold and the VDC pin is above 5 volts and shutdown pin is below 3 volts, the IC turns on and the low side output begins to oscillate. The IRS2158D enters preheat mode when VCC exceeds the UVLO positive going threshold and the VDC pin voltage is above the 5 volt threshold. The internal MOSFET that connects pin CPH to COM is turned off and an external resistor begins to charge the external preheat timing capacitor. The low side outputs and high side outputs begin to oscillate at a higher soft start frequency and ramp down quickly to the preheat frequency. The VCO pin is connected to COM through an internal MOSFET so that the preheat frequency is determined by the equivalent resistance at the pin labelled Fmin, formed by the parallel combination of resistors Rmin and Rph. The frequency remains at the preheat frequency until the voltage on pin CPH exceeds 2/3 VCC and the IC enters ignition mode. The IRS2158D ignition mode is defined by the second time CPH charges from 1/3 VCC to half VCC. When the voltage on pin CPH exceeds 2/3 VCC for the first time, pin CPH is discharged quickly through an internal MOSFET down to 1/3 VCC. The internal MOSFET turns off and the voltage on pin CPH begins to increase again. The operating frequency ramps down smoothly from the preheat frequency through the ignition frequency to the final run frequency. The IRS2158D remains in ignition mode until the voltage at CPH reaches half VCC, at which point it will switch into the pre-run mode. In pre-run mode, the fault counter is disabled so that the IRS2158D will enter fault mode if a single event occurs where VCS is greater than 1.2 volts. This allows the ballast to shut down if the resonant inductor saturates during ignition. When CPH exceeds 2/3 VCC for the second time, the IC enters a run mode and the fault counter becomes enabled. CPH continues to charge up to VCC. The operating frequency is at the minimum frequency and is programmed by the external resistor Rmin and the pin Fmin. During run mode, the end of life window, comparator and the DC bus under voltage reset are both enabled. The design of a dimmable ballast for the linear lamps requires that the lamp power can be reduced smoothly to allow a low output level, less than 5% of nominal lumen output. It is necessary that the lamp output is able to be held at any level and that there be no discernible flicker or instability at any level. The fluorescent lamp represents a complex load, the impedance of which changes depending on the arc current and temperature of the gases within the lamp. In the dimming control design, the ballast supplies the lamp through a resonant output circuit. The lamp power is adjusted by changing the oscillation frequency of the MOSFET half bridge, which is driven by the IRS2158D. The VCO within the IRS2158D is driven by the output of an error amplifier and compensation network that senses the lamp arc current directly and compares it with a reference. The SD pin of the RS2158D is used for lamp removal protection. If there is no lamp present, the voltage at SD pin will be pulled above the 5 volt threshold. When a lamp is removed, the ballast shuts down, and when the lamp is replaced with a good one, the ballast starts up again. During preheat and ignition modes, the end-of-life protection function, which monitors the lamp's voltage through the SD pin, is not enabled. Therefore, the ballast will operate as long as the SD pin remains below 5 volts. The device provides brownout protection for the ballast, which works by sensing the rectified AC line voltage at the positive output of BR1. When the VDC voltage falls below 3 volts, the IRS2158D shuts down. Without the brownout protection provided by the VDC pin, if a brownout did occur, the ballast would shut down, preventing the event of any hard switching. In order to successfully utilize the RS2158D in a ballast design, it is necessary to follow the PCB layout guidelines as shown. These guidelines can help avoid possible interference and ground loop issues that can occur in the ballast circuit. These guidelines also help prevent high current ground loops from interfering with sensitive timing component operations and allow the entire control circuit to reject common mode noise due to output switching.